So we ended the last video with transcription, and now we're going to move on to translation. So translation is kind of the end step of our protein synthesis. It's where we're going to take our message that we just made in transcription. We're going to take that message and we are going to translate it into something we can actually use. So we are going to start with an mRNA, a piece of messenger RNA, and it's going to have the code that we need to make the protein. This is all going to occur in the ribosome, and the ribosome, kind of like how you read words on a page, ribosomes are going to read in codons. Codons are 3 base pairs that code for one amino acid. So for example, AUG will code for one type of amino acid. And this is going to be very similar to those of you who take foreign language classes that have to translate from something like Spanish or French or German into English that you can better understand. So translation, when we look more closely at the ribosome is made up of 2 halves. I like to think of them kind of like hamburger buns that just kind of sit on top of one another with the mRNA closed in between them. And the mRNA is going to run through with its codons, and it's going to pair to these little key-looking things. These key things are tRNA, or transfer RNA. These transfer RNA are going to have amino acids stuck onto the top of them. So as the tRNA comes in, it will attach to each codon with its anticodon. Anti means not or against, so it's kind of the opposite to our normal codon. And each codon is going to prescribe a different amino acid. So for example, this white one, the red one, the orange, the green, the purple, and then the blue may all be different amino acids. And as they move through, one tRNA will stick in, add its protein or its amino acid to the chain, move over a slot, let a new one out, move over a slot, and then pop back out. And how we usually tell that which amino acid is going to be coded for is using a codon table like this. So I have 2 different examples of codon tables. One is a box shape, one is a wheel, but both of them kind of do the same thing. So for codon tables like this, say we start out with the DNA code TAC. We were to transcribe that to a piece of mRNA. So this is our DNA. Our mRNA will look, T goes to A goes to U, C goes to G. So our mRNA is AUG. So if we were to put that into our codon table, the first letter is an A. So it's going to be there on the box. Second letter, it's up on the top here. You can see there's a U, C, A, G. We're going to pick the U. And if you've ever done coordinates before, you just drop it down, drop it across, and we're in this box. Our third letter, you can see on the right here, we have UCAG, 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 UCAG. So we're just going to pick in our same row. The third letter is a G. And then we bring it across, and we get MET, or methionine. So our amino acid is MET. And of course, using our other codon table, so you see first letter, second letter, third letter, bring them all across. Our other codon table, arguably easier in my opinion, is going to start in the middle and work its way out. So again, if we use AUG as our mRNA code, A, go down to the middle ring, we have U, and then right down here we have G. So our AUG again comes out to be methionine. So when we are translating a full strand, the first thing that I like to do, and the first thing that I would recommend doing, is to just chop it up into little bits, because right now it's kind of messy. It looks like you just dumped a box of Scrabble pieces onto a table. So the best way is to break it up into its individual codons. So now we can at least see what words we need to read in order to get our protein. So the first one we said was AUG makes MET, methionine. Our second one is a UAC, so U, following along on yours. UA, bring it down into this box. UAC comes out to be TYR. Our third one, CGA, again, following along on your table. C, G, C, G, and A comes out to be arginine, or ARG. Looking at our last two, just in case we're going to do them both like we would any of these others. So UUG, you start with U, come down to this box, you see UUG codes for leucine, LEU. And the last one, same thing, UUG is another leucine. Okay, so take a moment, pause the video, and try your hand at these different examples. I know on at least the copies that I gave, I accidentally switched the U's with T's, so these should instead be U's, not T's. But go through, fill out the examples with what you think the protein is going to look like, and then we will go through it. Okay, so let's start with the first one. So let's break it up just like we had been. So AUG, we had said was methionine, MET. A is ILE, or isoleucine. UAU is tyrosine, TYR. CGA is arginine, or ARG. UCA is serine, SER. GU is glycine. And the last one, CAU, is histine, or histidine, HIS. Our second one, we have a lot of G's in this one. So our first one, again, AUG is going to be MET. GGG is glycine. GGC is glycine. AUA is ILE, isoleucine. CGC is arginine. And then this last one, UAG, you see is a stop. So this is a stop codon. This is not actually going to code for an amino acid. Rather, that's where the protein cuts off. That's where the end of the sentence is, kind of like a period. So our protein would be MET, GLY, GLY, ILE, ARG, end of story. The other thing you might notice, looking at our third one and comparing it to our first two, all of these have started with MET, or methionine. Methionine is typically going to be our starter amino acid. That is the one that is going to be the beginning of our amino acid. And if we were to do actual DNA coding, you would see that if we looked at a big strand of DNA, you wouldn't start making a protein until you hit this AUG, typically. So going through MET, CGA is arginine. UUA is leucine. GAU is aspartame or aspartic acid. So ASP. AGA is arginine again. And last one, UGA, is another one of our stop codons. So our last one will be MET, ARG, LEU, ASP, ARG, stop. So take the rest of the time, go over the video. This will explain a lot more kind of like what I did about how the protein is formed, what goes in, what comes out in kind of a different format. The Amoeba Sisters are really good at explaining different biological topics. So go through this video, and then once you are done, same thing, read or listen to the song,